Okay, so in this video today we'll discuss exercise 13.2 question number 12. Okay, so just look into the question. A die is tossed thrice. Thrice means a die is tossed 3 times. Find the probability of getting an odd number at least once. At least once means minimum to minimum one toss at least should have an odd number. That means even in 2 tosses you can have odd number. First toss, second toss, third toss. Minimum one toss you should have odd number. You can even have for 2 tosses also you can have odd number, or for all the 3 tosses also you can have odd number. Okay, that is what is the probability. You have to find the probability of getting an odd number at least once. Now please listen, it's a die which is tossed 3 times, thrice, and you know that when a die is tossed thrice, the total number of outcome sample space is coming out to be 216, which is absolutely not possible to write it here. If you remember, similar type of questions we have already discussed in the previous video also. Okay, so all 216 sample space cannot be written in this particular page. Okay, but ultimately we have to find the answer for it. So in that case, what I did is I just wrote the sample space of a die which is thrown twice. And you know, when a die is thrown twice, what is the number of sample space? The number of sample space is 36. This 36 sample space, I can write it here. Now, with the help of this sample space, I will find the probability of getting an odd number at least once. So, please remember, when you write the final answer will be the total number of outcomes out of 216. Okay. Now, what is the question? An odd number at least once. Now just imagine finding at least one odd number in the entire 216 is not easy to find directly. Okay, it is very difficult. So what we will do is we will find its reverse order. Now what is the opposite or reverse of an odd number getting at least once? An odd number appearing at least once. What will be the opposite of this? The opposite of this will be none of the tosses you should get any odd number. That is what is the opposite. Please understand, none of the tosses. Out of the 3 tosses, none of the tosses you should have odd number. So if none of the tosses, if you have odd number, then what number you will have? Obviously even number. If odd number is not there, means even number. That means find the outcomes wherein all the 3 tosses you get only even number. That would be easy. Easier than finding this individually. Okay, so we will go opposite direction. I mean, from the backwards we will come. So that is what I have written it here. That is probability of getting an odd number at least once, and probability of getting only even numbers. Together the probability is 1. Okay, that means success plus failure, together the probability is 1. So probability of getting an odd number at least once will be equal to 1 minus this plus p will go on the other side, minus probability of getting an even number. Now how to find the probability of getting even number? Now for that we will take the help of this sample space, this outcome. Okay, from here you just pick up only the even number outcomes for both the dice. Now let me tell you, the first row will absolutely not be included because everywhere you have some or the other odd numbers. So we don't want any odd numbers, we want completely even numbers. Now which are the even numbers left? So you just see I have circled it. Can you see that this is completely even number? 2 comma 2, 2 comma 4, 2 comma 6. Again, this row is absolutely not used because here we have all odd numbers, so this row we don't want. Coming to the next row, if you see 4 comma 2, 4 comma 4, 4 comma 6, both are even numbers. Now again similarly next row we are not using, so cut that, we don't want because we have odd numbers in that, we want only even numbers. Now last row, if you see 6 comma 2 is one even number, 6 comma 4, 6 comma 6. Now this is for 2 dice, 2 times when it is thrown. Now for 3 times when it is thrown, how will be the outcome? That is what I have written below. Few I have written. Okay, I hope you can understand. Now for each outcome, for example, if I take this outcome, that is 2 comma 2. If I take 2 comma 2, let me tell you, the third toss should also be an even number. Now what are the even numbers left? Either 2, 4, 6. So it can be 2 comma 2, 2 comma 2 comma 4, 2 comma 2 comma 6. For this each outcome you have how many sub outcomes? 3 outcomes. I have written here 2 comma 2 comma 2, 2 comma 2 comma 4, 2 comma 2 comma 6. Similarly for this one 2 comma 4 also you will have 3 outcomes like that. See 2 comma 4 comma 2, 2 comma 4 comma 4, 2 comma 4 comma 6. Similarly for the third one. Likewise, how many you have? I have circled it. 1, 2, 3, 4, 5, 6, 7, 8, 9 outcomes I have circled. In this 9, each 9 outcomes, you have 3 more outcomes coming up. So in total, how many number of only even number outcomes you will get is 9 into 3. So total outcome is 27 out of 216. Please understand this. Each outcome will have 3 more purely even outcomes. Here also you will have 3 even outcomes. Here also you will have 3 even outcomes. Similarly here, likewise you have 9 outcomes. So each 9 outcome is having 3 more outcomes. It is getting multiplied. So 9 into 3 will be 27 outcomes out of 216. This is the probability of getting only even numbers. That value you substitute here. So 1 minus 27 upon 216 is equal to 189 upon 216. That means there are 189 possible outcomes of getting an odd number at least once. I hope it is clear to you. Thank you so much.